Voyager 1 is back and stable, resuming its role as humanity's farthest-reaching interstellar ambassador. After overcoming significant communication hurdles that had left it transmitting garbled data since last November, this legendary spacecraft has reaffirmed its critical place in our exploration of deep space. In this video, we will explore how NASA's dedicated team addressed the spacecraft's difficulties, the pivotal role of the flight data subsystem in restoring communication, the exciting implications this recovery holds for the future of space exploration, and we will also tell the story of other probes. In our previous videos, we shared the suspenseful silence of Voyager 1 since November last year, and we shared that it broke its silence. You can find the link in the description. Now, we're thrilled to report that not only has this iconic spacecraft broken its silence, but it has triumphantly resumed its mission. Its 4 scientific instruments are fully operational once again. After months of complex troubleshooting and strategic ingenuity, Voyager 1's team has once again proven their mettle. The issue began when Voyager 1, our most distant spacecraft, stopped transmitting understandable data, leaving scientists puzzled and eager for a solution. The team zeroed in on the Flight Data Subsystem, FDS, a critical component that packages and transmits data back to Earth. This system, vital for the spacecraft's ability to communicate, had malfunctioned due to a specific chip. Engineers at NASA devised a plan to isolate and address this issue. By singling out the problematic code and relocating it to a new section within the FDS, they initiated a delicate process that required precise coordination due to the vast distance, as signals take 22.5 hours to travel one way. On April 20th, 2024, the team's efforts were rewarded when Voyager 1 began to send back intelligible data, marking a significant milestone in the mission's recovery. Initially, only 2 of the 4 scientific instruments were back online, providing partial but vital signs of life. Fast forward 2 months, and the news gets even better. Voyager 1 is now fully operational, with all instruments active and sending back data. This remarkable turnaround not only showcases the resilience and dedication of the Voyager team, but also highlights the spacecraft's robust design, which allows for such remote repairs and adjustments. In celebrating this milestone, we also recognize the tireless efforts of the engineers who worked behind the scenes. Their determination to restore Voyager, one not only salvaged a key source of interstellar data, but also reinforced the foundational technologies that will support the next generation of space exploration. Voyager 1's primary role, beyond the impressive feat of engineering it embodies, is to serve as human eyes in the interstellar medium. This region, lying outside our solar bubble known as the Heliosphere, is rich with materials ejected by other stars, offering key insights into the broader galaxy's structure and history. Since entering this uncharted territory in 2012, Voyager 1 has been diligently sending back data about cosmic rays, magnetic fields, and plasma waves. These crucial readings help scientists assemble a more comprehensive understanding of the interstellar environment. Cosmic rays, high-energy particles racing at nearly the speed of light, provide clues about the potential for life and the processes of star and galaxy formation. Magnetic fields, though invisible, exert a powerful influence, guiding cosmic rays and shaping the structure of the interstellar medium. Similarly, plasma waves are fluctuations in the ionized gases that permeate space. They aid in our comprehension of space weather dynamics and their interactions with interstellar winds. The recent resurgence in Voyager 1's capabilities was made possible by relocating software code from a malfunctioning chip to a different part of the spacecraft's memory system. This innovative solution not only circumvented the chip failure, but also ensured the continuation of Voyager 1's mission, allowing it to resume sending readable data back to Earth. This development ensures that Voyager 1 can persist in its critical role of transmitting valuable scientific data from interstellar space. Building on its technical triumphs, Voyager 1 has a rich history of contributions since its launch in 1977. It conducted detailed explorations of the Jovian and Saturnian systems, discovering new moons and active volcanoes, and collecting extensive data about the outer solar system. On February 17, 1998, it surpassed Pioneer 10 to become the most distant human-made object in space, a record it proudly holds. By 2012, it became the longest operating spacecraft, a testament to its durability and the ingenuity of its handlers. Its most significant achievement, perhaps, was becoming the first spacecraft to cross the Heliosphere in 2012, venturing into interstellar space where the influences from outside our solar system predominate over those from our sun. Thanks to the recent restoration of its full capabilities, the flow of information from Voyager 1 continues uninterrupted. Voyager 1's journey and recent triumph are part of a larger narrative of human exploration that includes several other pioneering spacecraft. Voyager 2, its twin, launched shortly before Voyager 1, has also made significant contributions. After a grand tour of the outer planets, it entered interstellar space in 2018, where it continues to study the outer reaches of our solar system alongside its sibling. Pioneer 10 and Pioneer 11, predecessors to the Voyager missions, set early benchmarks for what was possible. Pioneer 10 was the first spacecraft to travel through the asteroid belt and make a direct flyby of Jupiter, fundamentally changing our understanding of the giant planet and its moons. Its mission continued until 2003, long after its primary objectives were met, thanks to innovative power management that extended its operational life. Pioneer 11 followed a similar trajectory, providing the first detailed images of Saturn and its rings before its mission ended in 1995 due to power limitations. These missions laid the groundwork for Voyager by testing deep space communication and navigation technologies that are now standard in interstellar exploration. New Horizons, launched in 2006, represents the next generation of planetary exploration. After its historic flyby of Pluto in 2015, it is now exploring other Kuiper Belt objects, providing insights into the processes that shaped the early solar system. Its mission, supported by long-distance communication managed by the Deep Space Network, continues to stretch the boundaries of what we know about our solar neighborhood. Each of these missions has faced its own set of challenges, from technical difficulties and power shortages to the sheer vastness of space they must traverse. Each mission builds on the successes and lessons of those before it, pushing further into the unknown and illuminating the mysteries of the universe for us all. As we wrap up Voyager 1's journey, it's clear that this spacecraft is not just a machine floating through space, it's a testament to human ingenuity and the relentless pursuit of knowledge. The successful revival of its systems and the restoration of data transmission remind us of the incredible capabilities we possess and the boundless curiosity that drives us. Thanks for joining us as we celebrated this latest victory in space exploration. Stay tuned for more updates on Voyager 1 and other missions as we continue to reach for the stars and beyond. Subscribe to our channel for more fascinating insights into the universe and the technology that helps us understand it.